In this video, I'm going to discuss the characteristics of solutions, suspensions, and colloids. First, let's start with a little bit of review about mixtures. Remember that mixtures are a combination of two or more substances. If a mixture looks the same throughout, it is known as homogeneous. And if you can see distinct substances that are different from one another, it's a heterogeneous mixture. Some common examples are given down here in the illustration. Things like, air is a homogeneous mixture, whereas oil and vinegar salad dressing is a heterogeneous mixture. So a solution is a homogeneous mixture. It looks all the same, and it's made up of very small particles. Solutions can contain individual atoms or ions from atoms or even small molecules. A solution is made by combining a solute, which is the substance that will be dissolved, and a solvent, which is the substance doing the dissolving. Dissolving is actually a physical change, so the solute is experiencing a physical change, and the solute cannot be separated out from the solvent by filtration. If you took a solution and poured it through filter paper, everything would pass all the way through. Even if it was a colored solution, you'd be collecting a colored solution at the other side of your funnel. So why does anything dissolve anyway? Well, dissolving will only happen when a solute is more attracted to the solvent than it is attracted to itself, whether we're talking atoms, ions, or molecules. We've already experienced when we were talking about polarity that solutes that are polar will dissolve into solvents that are polar, and nonpolar solutes will dissolve into nonpolar solvents. In the dissolving process, the various particles of the solid solute separate from each other because of their attraction to the particles of the solvent. Water is an extremely important solvent, and we give it its own name. It will form what is known as aqueous solutions. And remember, we use that little symbol, AQ, in our chemical reaction equations to indicate that something's in solution. Water is a polar molecule. It is very polar, and that means it attracts both individual ions and charged areas on covalent compounds, which allows it to be a solvent that can dissolve many, many things, and it gets called the universal solvent. But of course, it's truly not universal. There are some things that will not dissolve in water. Aqueous solutions in general are very, very important in life on Earth. The biochemical processes that are happening in organisms that keep you alive are happening in aqueous solutions. And many geological processes, such as erosion or weathering of rocks to release the minerals in the rocks to be used by living things on Earth, also depend on water dissolving those substances. When ionic compounds dissolve, the ions separate, and we call that dissociation. And so the positive and negative ions will move away from each other. This is true when they're dissolving in water because water is a polar molecule, has both positive and negative areas on the molecule. The oxygen end's a little more negative, the hydrogen end's a little more positive. Covalent compounds, when they dissolve in water, they do not turn into ions, but because covalent compounds can be polar, there will be positive and negative areas on those compounds, and they will also then line up with the positive and negative areas on water. But they don't dissociate. They do not fall apart into individual ions. The compounds that dissociate are made of ions are ones that can conduct electricity, and those are known as electrolytes because ions are essential for helping an electric current move from one electrode to another. So in an illustration here, we've got a salt solution, and it will conduct electricity. The little positive sodium ions and negative chloride ions are able to carry the electric current from one electrode to the other and complete the electric circuit so the current can flow to light the light bulb, whereas sugar, which will also dissolve in water, will not conduct electricity because sugar does not dissociate, it does not become ions. Electrolytes can be strong or weak depending upon how many ions form during the dissolving process, and so the amount of electricity they will conduct can differ depending on the ions that are present. Here are some common examples of solutions. I want you to note that both the solute, the thing that is dissolving, and the solvent, the medium that it's dissolving into, can be solids, liquids, or gases. In chemistry class, we typically think of solid solutes being dissolved in liquid water, but of course our air itself is made up of a mixture of gases, so both the dissolving solute and the dissolving medium, the solvent, are both a gas. Another example of that is the things that we drink, our liquid, fizzy drinks consist of carbon dioxide gas that it is dissolving into water with some other flavors added there. So we have a gas and a liquid making up that solution. There are some cases where we have two liquids together. Alcoholic beverages contain both a liquid alcohol and liquid water typically that they mix together. And then we have various combinations all the way down of solids and liquids and gases to solids dissolving in solids, where we have certain metals that are known as alloys. We talked about that back in the video on mixtures. For example, to make combining bronze, you're combining tin and copper, putting those two together and creating a homogeneous mixture that is actually a solution. It's just solids in solids. Suspensions are the next category of substances that may appear very similar to solutions, but suspensions are actually heterogeneous mixtures that are made of large particles that gravity will pull on, and they eventually will settle out. They will go to the bottom of whatever container you're holding the suspension in if given enough time. The particles that are found in suspensions may be pure molecules of very large size, or they can be aggregates, like think about little bits of dirt that you could stir into a beaker, like we have the example in this illustration, that those are, those particles of soil are a combination of things all stuck together. That's what's meant by aggregate. Suspensions can appear homogeneous after mixing, but gravity eventually will cause separation, and you can also filter suspensions and separate out the particles. Besides sand and water, if you've ever cooked and tried to make gravy or pudding and you've mixed flour and cornstarch into water, those are also suspensions. If you wait long enough, the flour or the cornstarch will settle to the bottom. It will appear to be mixed in with the water, but is not dissolving. And then our third category are colloids, which are heterogeneous mixtures again, but they're made of medium-sized particles. So they're in between the size of suspension and the size of solution particles. They do not settle out. They are not big enough to be pulled to the bottom by gravity, but they can be identified because of something called the Tyndall effect. The particles are big enough in colloids to disperse light, to make it scatter around to show a clear beam of light passing through the container. So you can see we have a colloid here on the left of this illustration and a solution on the right. So the solution, we get a little bit of reflection on the glass of the beaker, but here in the middle we are no longer seeing the light beam because the particles inside a solution are so small that they don't scatter the light. Whereas in the colloid, we do see the light beam passing straight through the beaker. Depending upon the size of the particle in suspensions, they may also scatter light, but sometimes the particles are so large that basically the light can't pass through at all. Many of the common substances that you are interacting with every day are colloids, and again, it can be a combination of substances combining. The substance that is similar to the solute is what's going into a larger medium, which would be similar to the solvent, but they're not dissolving, they're not being attraction between particles, they're just sort of hanging out there. So smoke, like from a fire, is actually little tiny particles of solid that is being spread out throughout the gas. Same thing is true of fog, where you have little particles of water, little tiny drops of water that is in air. Marshmallows and whipped cream and many of the foods that we eat are also colloids, and certain special colloids are emulsions, where you have two liquids that typically would not mix together, such as water and oil, that can be held together by an emulsifying agent. So mayonnaise, if you put it on your tuna fish sandwich, it's actually made from combining vinegar, actually, which is high in water, and vegetable oil, which those two things would not normally stick together, but the emulsifying agent of egg yolk will help pull them together. Soap is also an emulsifier. That's what allows the grease to be removed from the plates or from your hands because it is able to combine that fatty substance with the water that you're trying to wash it off in. So just to summarize, solutions, suspensions, and colloids are all types of mixtures. The particles in suspensions are large and will settle out over time, and you can also filter them to remove them. Colloids will show the Tyndall effect when you pass light through it, and solutions cannot be filtered and do not show the Tyndall effect. And then just remember, aqueous solutions are extremely important for life on Earth. This finishes my overview of these 3 different types of mixtures. This unit is really going to focus on solutions, but I thought it was important to talk about suspension and colloids because sometimes they are confused with solutions, and so I wanted to make sure you understood the difference before we get started in this unit.